Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. So let's take a look at what we've got. Basically what we've been working on is strings. So if I cat the string.tasm file, we have push hello world. So we can run tasm on that. Tasm, and that's what we print out. Ignore the typo in there, but basically we can print out each character. I don't know what brokeout is though. And then we can run time on string.tin. And it almost works. This is the null termination character, and then we don't have the space there. So that is pretty much the problem that we've got. And I did want to address something. So basically, there's two ways to deal with strings. You can have null terminated strings, and it looks like that. Where basically this character is automatically placed there just to so that you know where the end is. Or you can have length strings, basically. Length of strings. So then this is 33. So you would say 33. Plus maybe a new line, so 34. Yeah, so basically, we'll say 33 to be accurate. That's the two ways of dealing with it. In the right syscall, if you don't know, we can actually take a look at that. If we look at right, so right, yeah, so you need the size in right. So basically, we could get the size automatically in the virtual machine, or we could just have the user provide it by going a little something like right 14, right, and then you do hello world, something like that. And I think I might just do that. So get rid of the null termination, because obviously there's no point in having both. So let's actually go into here. Actually, I think we do it in the parser. So let's see if I can find that. Let's say a string. Actually, it's not in here. It is in the asm.c. Yeah, it's right here. So basically what we're doing at the end here is we are setting it to that, and we don't want to do that. So if we do that, yeah, so I don't know what that's about. And then, let's see. Something we could do, though, is we want to check the user. Like, the user could provide that if they wanted that. I don't think I'm going to worry about that now, but we could have that. So now, if we build this, it's going to be a little bit different. So if we actually run this on string.tasm, yeah, so that's all the same, but it doesn't have the endline character. And then same thing here. But then we do have an extra D. So actually we do need to fix that. So it's in here. Because we are allocating, we are setting that, and then we are pushing it here. So so what's a good way of fixing that so that we could do I+1. So yeah, I guess we'll just do if head value.text I+1 does not equal that, then we'll go ahead and do this. Yeah, and then I think that should work. So now if we run that on string.tasm, there we go. So now we don't have that extra one. We still don't have the space though, so I'm not sure exactly why that's not working. I was planning on looking over that off stream, but unfortunately I don't have the time. So yeah, so I think we can just get rid of this now because we're not using that. So now that is working, but we don't have the space. So in here we do print it out properly, but it isn't pushing it. So is that, yeah, run tasm, we get the space. So it should be creating the space character, but for some reason it is not. Actually, let me see if we can do something like instruction value dot as char. Oops, I spelled that wrong actually. Value. There we go. Now we run string.chasm. Yeah, so it still does print it. So let's look in the tim.c, where we're actually pushing it. Push. Yeah, so we're printing it out here, and we don't have it in the instructions. However, if we comment that out, and then we do push space, I'm pretty sure that works. Yeah, it does. So, chasm, and we do print here. Tim. Yeah, so that works. So it's not an issue with that. It is some issue with the somewhere after this is not saving that character. Could we perhaps, if we, let's see, whoops, I meant that. There we go. So if we look in tim.c, so it doesn't print it out here. What is the program size? So maybe we could print that out. Print f machine program size, and I forget if that's a size T or not. And then I gotta save this actually. Yeah, it is size T. So if we reflect that, and then we run. Actually, I need to add some. All right, so it broke. Oh, because yeah, all right, it breaks when you don't have any arguments to it. So, whoops. String.chasm. There we go. So now it should work properly. There we go. Yeah, and then you run this. Yeah, so the program size 192. So that's not very helpful. Actually, it might be. So 192 divided by 8, 24. Okay. String.chasm. So 24, and it's 19. Let's see. So let's actually print, let's see. So that's each instruction. So why is there so many instructions? We have a lot of these in here. Whoops, I'm still in Python. There we go. String.team. Yeah, we do have a lot of those. That's not exactly good. Yeah. So that is kind of just a fundamental flaw that we do have. So that is being set in here, I suppose. So read program from file. So why is it reading to be so large? Length, yeah. So let's actually print f length is something like that, and then length. And actually length is an int. So oops. Yeah, so there we go. Whoops, I forgot to close that. And then let me actually, let's see. Let's get rid of that because that's gonna swarm us. String.10. So length is, I forgot the new line, but length is 192. So when it reads the file, it reads to that amount. Does this need to be length divided by 8 though? Actually, I still don't think that's right. So now it's print not again. Yeah, we still have a lot of these. Wait a second. Oh yeah, because we didn't actually change anything here. So divided by 8. Alright, yeah, so we want to set it there really. So now, there's not as many. It's still not right though. So I think there is a flaw where we're actually writing it. So machine, yeah, because the machine that we pass when we write it, it has a set program size. So let's actually look in the CASM.c, because that's where we are actually setting that. Program size equals program size. So let's print f program size and then program size. And let's see what it is. It's type int, okay. Yeah, so we'll run that on CASM again. Program size is 12, so that is more like what I would have expected, because we have well, we have 12 there, but we also have the but each one's an individual push, so 12 is actually correct. So why is it that is strange. So what if we do machine.program size, and then okay, it becomes size t. Still 12, but then when we write it, let's actually look at that. So we have string.tim here, and the size is 192. So that is, yeah, so that's where it's, when it's being written, yeah. So here, okay, well, it should be 12 times 8, right? I don't remember what that is. Yeah, 96. That's what it should be, if I'm not mistaken. Let's print what the size of machine instructions 0. So that should be 8. Yeah, I actually forgot to provide this here. So that is a I guess it is it's a zoo size of, and then yeah, there we go. So let's actually try that now. We want CASM 16. So each one is 16. All right, so that is why actually. Yeah, 192. Okay, so if we divide this by 16, then it is right. Okay, yeah, because it is not 32-bit anymore. Yeah, okay. So, let's see. 10. There we go. That is better. Yeah. No, it's that's a bit strange. So it doesn't actually print out the whole thing now. So why would that be? So is the length not enough then? Hello world. Yeah, obviously that's not right. But then if this is 8, then it is right. No, it's still not. So if we divide it by nothing, and let's not do not. Yeah, so did I modify the file? Thing.tagging? No. So what happened now? We did change the writing. No, we didn't actually modify this any. Yeah, we didn't modify anything here. So I don't know why that would be actually. Let's look at string.tim again. So it's still 192. It was working before. No, it's not. So yeah, I think that's gonna break it. Tab int. Yeah, put that in the wrong place. Something like that. So why is it not right anymore? I don't know what I changed. Let's look at the diff. So we changed that. Hang on, let me diff. Yeah, so we print F and we change that. So why is it not working now? I don't know. Phone is going off. Let's see. So what could be the cause? Let's print the stack. See what it looks like at the end. I can quit from that. There we go. And yeah, so it's all there. No, it's not. World. Get rid of that. So what happened? What if we just have hello? We got chasm. Okay. And it does hello properly. Did I not rebuild it? Yeah, hello. So that works. But then when we put a space, it doesn't want to work. Oops. We got chasm. Space work. Okay. Hello, old. So what is... That's 8. So I get rid of that. Is it Earl? Oops, I didn't mean to do that actually. Hello, old. So it's interesting. Hello, W. Alright, and then it just cuts off. So that is not right. So I don't need to print that anymore because that should be working. Hello world. So if we build that again, showing our chasm, we can look at this, it prints out properly. Still printing that. That's in here though. Hello Earl. So now it is closer. So that's obviously not gonna work. Yeah, now it does some crazy stuff. Yeah, now it's probably a massive file. Yeah, so we obviously don't want to do that. So for this, what if we do size of machine divided by size of machine instructions 0. Chasm? Yeah, chasm. 513. So why is that so much? Oh, I actually want machine instructions, not dot instructions. Okay, like that. So that's 1. And then, yeah, that doesn't compute the number. Yeah, so that is, Let's actually print the type. Type is, and we're not gonna be able to get it perfectly because I don't have something for printing all of these types, but we can see the number and compare them. So if we build that statement, oh yeah, this needs to go right there. So now if we look at that, type is 0, so that's the notes that we are getting. Type is that, so that is weird. Hello, yeah, so we have an issue with that. Let me change this to be that, so it is, doesn't have all the extra stuff in there. Alright, this is kind of hard to read now, so what's a better way to do this? So, L, yeah, so this, type is that, so that is the missing one that we have. It just is set to an out of bounds thing, but it should be the same as the others. Yeah, so it's different every time. So it is just, is it negative? So why would that be an issue? So can we actually iterate through? We do something like for then machine program size, and then type is machine instructions. So I do, this is needs to be dot. All right, but it is int. Yeah, we need to do dot type. Dot type, and where did I? Oh yeah, right here as well. And now, that's fine. That's fine. So if we do not chasm, yeah. So we have a lot of extra stuff in here. Yeah. Let's do divided by 16. Alright, maybe that's not right. Let's just do regular program size. It doesn't work because this. Oh no, so that's right. So yeah, it is being set incorrect. So now if we run this, yeah, so that's the same. So for some reason, let's see. Type. Okay, yeah, we want instruction type. We want that. So it is 1 all the way to there, but then when we exit, it is not. Yeah, let me get rid of this. We can make a loop. Yeah, so it's 1 all the way, and it is 11 characters, and I think that is right. Yeah, so that... So when does it get messed up, actually? Push program. Let's see. Perhaps it is equals value. Inst value. So we're setting the type properly, but when it gets pushed, let's actually go here and do program size. Yeah, program size -1 dot type. chasm. Yeah, so it's still 1 here. Construction. Paid value. Sorry. Let's see. If I set this directly to be inst push. Yeah, it still doesn't work. So where is that happening? So it's somewhere down here. So after this, instruction sequence program. So it can we iterate through the program? Program. It doesn't like me typing within comments. Program. Let me uncomment this. Program. There we go. And we got chasm like this, and there's still a problem. Putting out a lot of times because we have it up here as well. So why is that? Okay, so that is why. Yeah, perhaps we do have the times program side. Then we need to do something like that. No, that's not what we want. Yeah, so we need to well, we could write something to get the length of this, and we just want to multiply it by that. So let's do well, actually t size t. T length of list. Parts list head. So while let's do yeah, so let's do actually parse list temp equals head. And let's do that actually. Wall temp does not equal null. Temp equals temp next. And then we'll basically just do times the result equals 0. And then result. Well, actually we should start at 1. Result, let's see. That's equals 1. And then return result. And we should not super efficient necessarily. We could calculate it in the actual parser, but for now this should work. So if we pass that head in there, chasm. Okay, so it did not work. Let's whoops, I just completely messed that up. Length of list head, and let me get rid of all the this one at least. Whoops, that's not what I want. I want that one. We got chasm, and it is 3. Why is it 3? So that's not quite right. Next. That's even less. Yeah. So temp equals head. Now if we go back in here and we get rid of that. Well, so that works. What if we make it a longer string? Get world, that's not much longer, but chasm, string.10. Hello world, alright, so that worked. And then hello world, how are you doing today? I need to recompile it. how are you doing today? All right, that looks pretty good to me, actually. And let's see, so if we add this, it's not going to be reflected in there. String out thing. The 0 is though. Actually. Okay. We add a new line though. Because it should work. It should be structured to work. But it just makes an N. Okay, that's not good. Yeah. That would actually be in the Lexer. Actually, let me go back into here and let's print the value. Oops, value is, there we go, instruction value.as char, build that, and that puts work. Yeah, it needs to be instruction, and we can get rid of this now. Right, string.tasm. So we get that, but we want to see with a new line actually. New line, and now it's an N. So I thought that was working. Well, let's see. So in the string, generate string. So do we not check it in here? Okay, so if escape character is that, do we not ever actually set it to the escape character? That might be the problem actually. So we should set current index equal to escape character. There we go, and string.tim, and now we have a new line. So that is nice. Gustav4151 just followed. Thank you, I appreciate that. Follower number 69. Very nice. Very nice. Yeah, so let's run that again. Yeah, so it just cuts off when we do that. That is what I was expecting, and that's what expected behavior for now. But yeah, so that seems to work. Actually, we want to do something like that. Because, yeah, we want to set it after. So if we do something like /1, that is invalid, so it won't work. But if we do /1, then it should work. Yeah. Then we have a... Alright, yeah. So that is correct. Yeah, so let me move this to just be regular hello world. Hello world. With the new line and everything. So, I didn't mean to reload. So now we have the string. So we need some way to write it. So we'll do write 14. So that will be how to work basically. So we'll use the C, write in C. If we look at that, write inc, it'll load ever. Might not. Things get really slow when I stream. Write in C, that's what I meant to do. Alright. Right, yeah. So we can show an example of it, if it'll load. Right, yeah, file descriptor, buffer, and so we can see an example. This is a nice example, actually. I think it's just because it hasn't loaded all the way yet. There we go. Alright, oh, okay, this is fancier than it needs to be, but okay. So, yeah, have the right. So, empty. So that's just, so we would want to write to, yo, Schooly B, how are you doing, my man? Yeah, so we would be writing to standard out. Normal. Well, actually, we could probably provide that. So 1 is standard out, I believe. 0, standard in, and then 2 standard error. So we would want write 1 and then the length. Doing well in you. I am doing quite well myself. So that's how the syntax will look, kind of. Yeah, and so the buffer is the string. So we'll get that from the stack. So basically, what I'm thinking is when you put it in, it'll go to the current stack size minus the length you provided, and then it'll just keep going up from there, and popping it out as it goes. So after you execute the write, then the stack will be empty, at least in this case. There will be nothing on it. Yeah. So that's basically what I am thinking. This is 14, right? Yeah, 14, because that's a single character. Yeah. So that is kind of what we want. And we have, using our include in the test, we have the Linux sys calls. So yeah, you can do syswrite. We do need a cross-platform way to handle this, because right now, at least, this would be exclusive to Linux. But yeah, you could do syswrite 14. Yeah. Or if you want, actually, that's not what I want. Whoops. I meant it is in inner depths. It's right here, actually. So it won't be syswrite. That's the syscall. It'd be that. This is still Linux exclusive, but so that's standard out, or you could do standard air. Yeah. So that is something that you could do. Yeah. So let's actually try to implement that. So it'll be its own instruction. In the future, it might be better to kind of refactor it. So it just uses a syscall built in. I'm not sure how to do that though right now. So I'll implement it how I can figure out to do it at least. And then we can change it later. So let's do, I think, I want to make sure I don't break things, but I do have this here. So this goes, yeah, to inst count. So we do have to update it. So we'll do inst write. And the print could be used for that, but really that's just for debug at the moment. So inst write. So we have that. We do need to add it in here after the print. We can yank this, and basically, so it is going to have 2 arguments. So we don't have support for that at the moment. I don't believe, because if we actually look, here's what we have. So the type and the value. It needs to have another value, length or script. I spelled that wrong completely. Yeah, we'll just do that. So we had the value and then the length. I don't know if that will break things actually. Inst write not handling switch. Oh yeah, this needs to be, yeah. And let's see if it still works. Yeah, we don't actually have that. So let's build fib. No, that's not what I wanted. That's fib.tim. And that seems to still work. So why did it print out? Is it up here in the right? Perhaps I actually did that. Added, no, it's in here, I suppose. It is indeed. So it's right up here. We can get rid of that. Yeah, so alright, so I think that'll work actually. So for most things it will be empty except for the right, at least at the moment. And we could repurpose it later, maybe rename it and such to make it a bit more general purpose, because right now it's kind of specifically for write. But that's okay. We can always refactor later. That is what I'm thinking. So in the Lexer, we need to add, it should be fairly easy actually. I think we just need to go into here and then do that, right? Type right. And then in the Lexer.h, we need to add type right into here. Right, and it has to go in the right place, because we do have stuff that relies on that. Yes, so that might be all that we need to do here. So now if we, it's still gonna break at other parts, but that's in the 41. yeah, in here, we do need to handle that. So, right. Right there. This order doesn't technically matter, but it's less confusing if you have it in the proper order. So yeah, it didn't work. But we did get farther. So I think it generated the right token. So we can actually make sure it generated the right token. So right. Yeah, okay, so we do need to include the next int for it though. Well actually, yeah, so it's set right to be a type of int. That's kind of weird. So in the, did I spell something wrong? Right, type of right. Okay, actually I think that needs to be right. Alright, yeah, so that's actually just prints before it. But that should be good then. I believe that is working. So text hello world, line 1, character 6, right. And then, yeah, so that's actually the string before it. Here's the right. Yeah, so I think that is working now. But we do not handle that anywhere else. So parser.c, we should be fairly simple here. So basically we want to check, yeah, we can basically do if open stack index type equals type push. Then yeah, we want to do, no, it's not type push, type right. Then we want to do something similar to this, but we only want to be followed by integers. That's all that we want. So we can grab this and then adjust it. So index plus plus, and then current token equals that. And we just want the type of int, because nothing else would be valid other than an integer. So let's get rid of that line entirely. Something like that. Expected type of int, and that's it. And there we go. Int hello. There we go. Type of int. Do you program professionally? I do not. Right now I am in school. And I'm majoring in software development. So one day, hopefully, but at the moment I do not. Yeah, so type int and then index plus plus. And just do this exact same check again. And then we are all good. So, and token stack. Token. Nice man, I'm sure you're going to kill it. Thank you. Alright, let's see. So what do I need to append it more than once though, right? So we append that, yeah, so we want to append after this one as well. Yeah, so I think that should work. So that's in Tasm.c. So we can actually print the list here and make sure that it generated it all properly. So let me go back to the Lexer, and we can take a look here. Okay, so that, yeah, this is what we are printing out, I believe. So push, hello world, right, and that. And if we get rid of, in here, if we get rid of the 14, it should not work. Yeah, we found no. Okay. Well, I think that is a bug, actually, that I found. Nope, but that's okay right now. I will keep that in mind, though, because obvious. Yeah, so now in here, this should be set up, so we should be able to just equals push, then yeah, so yeah, so we can do a similar thing to this, except it can't be exactly the same. Basically, what I'm thinking here, I really should just do that. If head value.type equals type right, then let's see. Just like that, and there we go. Alright. Type right. Maybe I don't know. Yeah, so we want to do that. But then we also want to do the same thing again. Head equals, yeah. So at this point, that should be valid because we do check to make sure that it is followed by 2 integers. So, yeah, so that should work. Something we should add as well at some point is support for basically the type of whatever the instruction is, or in the word at least, because right now we have this, right? We don't have a type for it, so we don't know. Like we have the value set in here, which is just one of these. We don't know which one of these it is, and we do need a way to check for that, because that would make a lot of things much nicer. I'm not going to do that now, but in the future, then I'll want to do that. So we want to do that, and then, yeah, we actually want to push this one because we are doing it more than once. So we want to do similar thing to what we do here. Yeah, and then the next one it'll get automatically pushed. So if we go like that, we can actually move this one down here. Yeah, so we don't want that. We want it here. Yeah, and then inst right. So we don't want that one either. Yeah, basically that's what we want to do. And then we allocate a new one, and then we set the type to right again, and then do that. So no, we don't want multiple rights. Actually, no. I forgot that we added that other thing. So we want the value, not value. We want the length to be equal to that. So let's build that. String like that. Okay. So now the right is not implemented. So let me actually reflect that in here. So in here we have right. Actually, assert false and not implemented yet. So that should be called. We build that and then, all right, false and not. All right, so we did get there properly. So we should be able to. We don't want to just pop it like that. We want to do. We want to call the right syscall, and we want the. Well, let's see. So we want the machine instruction. The dot. Let's see. So this isn't the length yet. So this is the value, because that is going to be the file descriptor. And then we want the string in here, and then we want machine instructions IP dot value dot as in. Yeah, so that's what we want. Let's get rid of the print. And so this isn't going to work now because we don't have the string, but we can add a test. So let's just hard code hello world here. And let's see. So I probably did something wrong. Do I need to include? Yeah, I need to include the which one is it? This one, I think. So let's actually go to the top and include that. Actually, we'll do it in here. Include, whoops. There we go. And now it should compile. It did not. Sense of word. Yeah, so we want this to be, this should be length. I did it wrong, actually. Length, and this should be dot as in. Wrong order. String dot as in. And alright, so it did write properly. And if we change this, then I think it'll just write nonsense or not. But it shouldn't write past that. Hello world Jack. Yeah, so it doesn't. So that is good. So now we just need to basically we need to generate the string. So let's do, we need scope in here. Something like that. Maybe like that. So we want string dir equal to get dir from stack, something like that. And then we want to just pass the machine instructions IP dot, and that's basically, we'll just get it from the stack like that. And we also want to just pass the machine. I think we don't need to include the length like that because we could just get it from the machine, but I think it would be easier if we do that. So get dir from stack. So let's actually write that. And the names of any function are subject to change. So let's do it above this, above right here. So that will return a string. So we need the machine and the int length, or maybe size t. Let's do it. Yeah. So we need to basically subtract from the starting at that one. So basically the machine stack size minus length. And then we can do length minus 1. Yeah, so basically this is what we want to get. So we want to get machine stack. And then this is the index. Yeah, something like that. So let's actually buffer equals malloc size of char times length. And that's what we'll return actually. And return buffer. So while length is greater than 0, we'll do that. And actually we do want to append it to the buffer. So we'll do int buffer index equals 0. And we'll do buffer index equals this one. So I think we can just paste that in there. Oops. Okay, so let's see. Buffer index equals that. Yeah, I think that should work. We should return the buffer from there. So we want to do that. And then here we want to just pass the string. So this isn't quite right yet. Alright. Yeah, so we want to get it as character. Yeah, so that is dot as char. Okay, statement with no effect. Length minus 1. That's what I wanted to do. String.asm, string.tin. And it didn't work. Let's print the buffer actually. Buffer is buffer. We don't need to do that. String.tin. Buffer is not. So that didn't work. We didn't iterate the buffer index. There we go. And buffer is hello world. Okay, and if we modify it, let's see, where are we doing that? And that is in here. Hello world. And so if we change it without changing the length, then JK. Then hasm, tin. Low world JK. Yeah, so alright. So that is almost exactly what we want. If we change this length to be 3 more, so something like that, then it should work properly. String.tin. Yeah. Alright, so that is good actually. Now the only thing that we have now is that it's not popping it off the stack. Or really removing it. We basically need to just, well, so let's look at how pop works. We just remove it from the stack size. So I think we can do at the end here, we can just do machine stack size minus equals length. So let's actually add a if length is greater than machine stack size, then air stack, just do air, actually we'll make it consistent, stack underflow. Underflow, there we go. Don't need that. And then exit. So string.10 stack underflow. So now it should not do that. I need to recompile it actually. String.10. Okay, so that worked then. So we can't we can't have it be greater than that. It doesn't really matter if it's less. It will just be like if you just put 4 here, there will just be empty characters on the stack. That's like user error. So yeah, so now we have right, and it pops everything off the stack. So we can actually show that. If we go to the end of the loop and then we print the stack. Let's see. Print stack machine, something like that. String.10. Oh shoot, so it's all still there. Okay, so I must have done something wrong. Yeah, alright, that is funny. So let's see, read, right? No, it's right here. So get string from stack. So does this not update the stack size? So I don't know why that would not do that. Let's print f. Machine stack size. I think it's actually just an integer. I don't know why I added those curlies. I meant to do that. Yeah. So let's do something like that. And then we'll do it before as well. So then we can see. We don't need on that. Not 10. So if we scroll up here, so 14 and then 14. So it didn't actually remove it from the stack size. Equals stack size minus 1. Will that work? No. Seems to be machine stack size. It still didn't work. It's still 14. So we're not actually updating it here. So let's just pop then. Let's do pop instead. So then wall machine stack size. It's not equal machine stack size minus 10. Then we'll just do pop machine. So now let's print this before and after. And whoops. There we go. I'm not sure what that was about. Yeah, that, and then let's see. String.10. Still didn't work. So does pop not work? Seems to not change the stack size any. Perhaps it seems to be a double pointer. Actually, let me go down here and pass in right, yeah, and then 55G. Let's do something like that. Just add this to all of them. I can actually replace that. If I do something like that, and then place machine with machine, and then the place that I added it, I have to change again. There we go. There we go. All right, and now, so where is that at? Oh, so it needs curly braces, I suppose. So we can query replace that once again. So let's do replace that with, oops, I forgot that, machine, like that. All right. And then there's still a place that did not work. Well, here we can do that pretty easy. Let's see. That is 52. That's right in here. Uh-huh. Yeah, it still doesn't work. So what if we... Alright, let's undo all that. Because not do that. Let's undo all this stuff that I did. Just like that. And then let's take this. Like that. And then go down here and let's do it just in here. Yeah, so we can do that. Next link. Length undeclared. Yeah, so the length is actually machine instructions IP. Alright, int and size t. So is the stack size, is that a size t then? No, it's an int. So not sure what that is then. So this one is size t. As if the int like that. There we go. String dot tim. Stack underflow. Okay. So it works like this then. So okay. So let's just do something. Let's just do that. Minus equals machine instructions IP dot length. And there we go. And there we go. So then it worked. That's how I expected it to work. But now we have it working. So work. Yes. So now we have support for strings, at least some iteration of them. Quite certain this is completely the wrong way to go about doing it, but it was just a way I thought of, and it does work. It's not ideal probably, but it works. I can always re-implement it later as I learn more. But yeah, so now we should be able to do this as many times as we want. Again, and then, so we write 1, and then 6, not 6k, and then that should work. And there we go. So again, all right, we can actually get rid of that print statement up here. Let's see, where is that? Right there. And that will make it go that again. That's it. Again, hello. So we are printing that still in the push. And then also in here we have the printf. See, that is right here. I just want to get rid of all of the debug stuff. So that is, that's in the parser where we are printing the list. Let's not do that. All right, and build it again. We got Tim. Okay, and there we go. So now there's no messages like that or anything. Yes. So let me commit that then. Hit commit, and let's see. So this will just I need support, full support for strings, as well as writing them to either standard out or standard error. Using write. And we'll push that. So it wasn't a huge change, but it, it's a pretty big thing to have supports for strings. So we can actually update the hello world example. I probably should have done that before pushing this, but that's okay. Yeah, so let me do that. And let's see. Alright, so let me make sure that worked. And yep, all right. So now, yeah, let's actually update the hello world. So let me remove the string.asm. Yeah, and then I will remove. Let's do get clean actually. There we go. And then I will touch. Let's see, hello world.asm. So yeah, we can actually have a proper hello world now. So I was modifying it here. So we'll push hello world. We don't need semicolon, and then we will write 114. Actually, let's do at import. Let's see. So, yeah, dot catch, and then instead of this, we can do standard out. Yeah. So then, we don't have a way to compute the length of a string at the moment. That would be a cool thing to implement. But for now, that should work. So if I actually move hello world.tasm to test, and then yeah, that should have replaced the one that we had in here already. Hello world.tasm. All right, so let's do hello world. Okay, I didn't build it. So there we go. Hello world.tim, and oh yeah, it's time. All right, hello world. There we go, and it worked. The import worked of the standard out. So this is pretty clear what it's doing actually. I think it is pretty good. Let's see. Hello, Mr. Cobb. Hello there, Anthony Slab. How are you doing? How are you doing? There we go. Let's see. So hello world dot Ivan. Hello world dot. I'm thinking. So right now I call it Cobb of what? Corn? No, that's actually my name. Well, my last name. Yes. So it's not Cobb, like corn, not like corn. Yeah. So that works now. We have the extra space in there because it looks nicer. And yes indeed. So right now, the building the test doesn't work because the including files, the way it's set up. So I do need to fix that by changing the working directory to be the test folder. I don't think I should probably add a way where you can include the standard libraries, just where it's like that, like in C, something like that. But I'm not going to do that right now. For now, we can just do that, and that works. So, yeah, anyway, as I was saying, so time right now is what it's called. Which is supposed to be Tim Emulator, C Lover. Yes, I do love C. It is quite nice. Well, no, it's got some problems. It's not perfect, but, C is pretty good. Yeah, a lot of people don't like C though. Yeah, so basically, I think I'm going to change it. So right now it is time, meaning Tim Emulator. I think I'll call it Tire instead. So it'll be Titanium runtime environment. So then it's like the Java runtime environment. But then it can be Tire, and I don't know. I feel like that name's better. So I think I can do that pretty easy. I hate that and that for include paths. That's fair. It makes it easier, at least in the well, like in Python, you don't need that. C++, I think it similar way to C. Like, why do you hate it though? It makes it clear where it starts and ends. Yeah, I don't know. I don't mind it. Yeah. So I can do that pretty easily. So basically, we can just move time.c, tire.c, move time.h to time tire.h. And then in here, whoops. See, tire.c, just end with a semicolon. Well, you could do that. That's true. I don't know. Well, I don't know why that. Yeah, I guess that would make sense. Yeah, it could be like that. I see what you mean. Yeah. Yes. I do see what you mean by that. So that is in... Oh yeah, I need to actually change the build.exe. I mean, I don't mind it the way it is, but I do see what you mean, and I don't, like, what's really the benefit to doing that, though, you know? So that's actually right here. It's higher. So let's see where else we fail. I guess I didn't fail anyway. So, TASM, and then test/fib.tasm, fire test/fib.tin, and it all works. Okay, yeah, it all seems to work. So that's pretty cool. Yeah. So, what to do now? I don't have much more time left. Before I have to end the stream. But make sure this is still working. Yes. Wait. Oh yeah, I didn't actually remove the time. Tired on hello world dot, yeah, there we go. Alright, so there, I just changed that name. It doesn't really matter, but alright, so I can push that now. It's a rather small thing, but so basically we changed time to type Indian runtime environment. And then also what else? Also updated the hello world example to use strings and right. Looks better, less typing, more consistent, and know that. Okay, that's fair. That is fair. So yeah, so let me push this. I mean, C's obviously not gonna change now after all this time. They're not gonna change that. Would break some stuff. But yeah. I mean, I could update my preprocessor to use that. And I might do that. I'll think about it. It wouldn't be that big of a change. The only thing though, I guess, the way I'm using it, where it's in assembly, it doesn't end with semicolons. So we could check for a new line, but right now, this way, it works all on one line. So for mine, I think that does make sense. Yeah. Because the assembly, it doesn't, I don't want to add semicolons to all the new lines because it's not really necessary. Yeah. Did my stream die? Is it dead? Doesn't mean we can't hate on it. That's fair. Yeah. So is my stream still working? Because for me, it is not. My Wi-Fi might have died. Yes. It looks like. Okay, I think it is not dead. Okay. I think it's working properly. Alright. So let's see. No, it's still alive. Okay. Yeah, my Wi-Fi kinda dies sometimes. So yeah. Alright, so let's see. What do we need to do now? So yeah, so basically the way we handle strings, it is just characters and then with a length, essentially. So if you look at the stack, if we actually print the stack, if we don't write, so yeah, let me close this because we don't have that anymore. So let me just test.tasm and open up test.tasm and we do push string like that. The way it looks, I have to print it actually. So we'll just print the stack at the end. Print stack machine. And I completely messed that up. Machine. Yeah. So build that. Test.tasm. Wi-Fi issue. Alright, yeah, so this is what it looks like basically. It does look backwards, but we handle that. Yeah, so that's basically how it pushes it. which that probably isn't the best way to do it. And we don't use pointers at all for it. Found this burger place today. In-N-Out Burger. Yeah, so that's probably not the best way to handle it, but oh, you know what? We can update the print stack. Because right now we don't print it as a pointer. So that's pretty easy to fix. Whoops. No. That's not what I meant to do. Stack. Yeah, right here. Yeah, we can do as pointer. As pointer. And then we can do, let's make this look a little nicer actually. Well, found is a strong word. I've always passed it on the way. Alright, what was it called? Was it like a chain or like a local place? Maybe something like that. Yeah, and then put as pointer. Machine stack I.as pointer. And then we can display it as a pointer as well. So we can just do that. And there we go. Yeah. So that allows us to see it better. So we don't utilize that at all right now. But obviously we will. That's going to be very useful for things. Close that. Yeah. Okay, so let's see. I think that's probably gonna be the let me get rid of this actually. I could implement this. Yeah, okay. So I never actually implemented mod, I suppose. That should not take very long. Just print the pointer to the user and it's up to them to dereference. Bruh. Alright, yeah. So hang on, what was I? Yeah, so that's not fun. So we can do that. Push pi, push 2. Wait, so what? Oh, we don't have mod F. So that is actually alright, yeah. So mod F. So we want this to be 5.0, 2.0. So this should say not implemented yet. Test.evan. Higher test.in. Yeah, not implemented. Never seen it before, so I assume it's a local thing. Okay. What's it called though? Or well, I guess you probably don't want to dox yourself, so don't have to answer that. Yeah. So for this, mod F. So what is this thing that I have here? Didn't feel like a chain. Alright, that is fair. Alright, so that doesn't work. So, okay. Alright, it's not 10. So, at 0. So that's not right, obviously. Should be 1. So I'm not sure what that is doing. So let's look at mod F. Yeah, let's see. Mod F. So, how do you use this function? Guess I could use a man page, but whatever. Probably would load faster than this. Yeah. Integer. This is the pointing to object where the. Okay. Okay, so that's where it's supposed. Okay. Alright, so that is kind of interesting. Alright, let's actually look at mod of floats in C. I don't actually remember, but they had the stereotypical Texas themed decor. Only work with integers. Yeah. So F mod. So it's not mod F, it's F mod. That might be the one that I want to use instead. So if we run that, it doesn't work. We did not include. I think we have to include that. All the doxing. Yeah. Yeah, I think it is in. Oh, we do have math. So, right. If this ever decides to load, you can look at the man page. Math library. So do we link with that? So what do you have to do that? I don't remember. Fmod. Mm-hmm. Yeah. Fmod. So yeah, let's see. Wait, that ECC. That's what I'm using, right? Yeah. Good food though would go again. That's good to hear. So fmod, yeah. So that I think is what I want. And let's see. So that's down here where we have the mod f. Right. Could have searched for it, but I didn't. Yeah, mod f. So here we want to push that to pal. Oh yeah, ln. That's what I want. I just forgot what it was. So dash ln, and I could make it a much better build script. Definitely. So it still doesn't work. I did the wrong one actually. Dash ln. So no need to do this one. At least not now. There. Nope. All right. So that still didn't work. So is there a different thing to get the link? Let's see. Or is it IM? I was forgetting. No, I don't think it is. I'm quite certain it's not. Yeah. Alright, let me see. Perhaps I used the wrong thing. Oh, I didn't know you could move them like that. Okay. There we go. Yeah, so it is ln. So why it no work? So do I need to add it before the edit kit? No. So fmod, it's not work. Do I not have that installed? I'm pretty sure I do. Uh-huh. Yeah, well, it's standard, so it should be installed. Bum, bum, bum. With the L flag. Okay. Okay. Undefined reference. Yeah, so it doesn't like that. And I am including it. So why doesn't it like it? Let's put it up here. So now I'm including it twice. Yeah, it still doesn't work. I wasn't expecting that to fix it. So why is it undefined? I'm not sure what I am doing wrong here. Yeah. Fmod. So, yep, with double until that. I don't know what C version I have. That's C++ though, so that doesn't matter. Yeah. Long double. I don't think that is what we need. Include CMAC. So does this only work in C++? Dash V. Let me actually make that back here. No. Use claim cannot help a trigger. Well, yes. Well, this is GCC, so yeah. I don't know. I'm linking that, but it's not working. Yeah, small v. Yeah. Figured it out. Okay, so I had to add it to both of them, I guess. Okay. Glad I messed around with that for so long. I'm kind of tired. Hey, what am I? Why do I have hello world.tasm in here? Yeah, I can use that. Hello world.tasm. Let's see. So what do I want to add though? I want forgot what I was even doing. Okay, tired. Yeah. Test.tim. So there we go. Now it is 1. Yeah, so we pushed as a float, which that makes sense because so now we have floating point mod. So we could make this 7. Well, let's make it, let's see. We don't use 2. Let's make that 10. There we go. We'll just find it. It was Matt. I got it though. And the problem, yeah. Figured it out. I think that the stream is a bit delayed. Yeah, so let's dot that as in and test dot 10. And there we go. So that works. Yes, indeed. So we need 10.5. And then it should also work for that. Okay, test dot 10. And there we go. 2.5. Yes, so it's all working now. That's all that I want. So let me remove test.tasm and remove test.10. And then make dash m implemented floating point mod population. Push that. And there we go. If it'll ever load. Yeah. Alright. My internet service provider does not. I'll try using. Yeah, I know. I know all that. I just haven't done it. Yeah. I will. So I think that is good then. Yeah, my internet service provider does not like me streaming. It makes everything very slow. Or maybe it's just my computer. I'm not sure. Okay, and it seems to have updated. Okay. Let's see. Alright, so I can actually update that readme, and then I'm going to have to be done for the day. So let's open the readme. So let's see. That's all good. But then I want to just remove that, and then readme has how many operations does it have? So we have. Well, it's technically only 29. But we could say 30, even though currently, well, it currently has 29 instructions. ISP issue. I'm not sure. I don't know. I don't know what causes it. It could be my computer or just not enough bandwidth. Yeah, I don't know. Currently has 29 instructions. This can be found in pin.h. So let's see. Example of assembly is, let's do something like that. Whoops, that was way too many. Alright, and let's do ASM. I think that'll work. Like that. Whoops. That doesn't like that. There we go. Okay, so I'll push hello world. That, and then right standard out 14, and at import let's see standard def dot attach. So basically, yeah, this shows a lot of the parts dealing. So it has the push operation, has the preprocessor where we import that, and then also has the write syscall. So example of hello world in assembly. So yeah, I think I might be doing the markdown wrong, but that should be let's see, VM currently, that's that. It is also a working assembly which contains support for all instructions in the VM. Yeah. So I think that is probably all that we need to do for now. So let's just hopefully that works. Updated and push. Yes. Okay. There we go. And now if you look at the README, should be better. And then I'm gonna end the stream. So yeah, there we go. So that looks pretty good, I think. Yeah. Some stuff like this can be a different color from the keyword, but that's okay. Yeah. So that shows it pretty well. I should have a new line there, but that's okay. Yeah, so that it's not perfect. I could write a whole longer README. I'm not gonna do that right now though. Yeah, so that is pretty cool. Now we have